So I'm mostly not going to present a decision support tool, but more a kind of a discussion. So this is kind of work that's done by me and Philip Dietmar and David Pissinger. And Christos Kantovas and Christos and I have received money for this project, Maneco, from the Maritime Foundation. And the project is a project which deals with maritime management with a focus on emission control, and also some parts about education. So I'm actually going to do this in a respect to liner shipping, but I think you can abstract from that a little bit, because I'm working with liner shipping because I'm used to collaborating with Maersk, and so this is easy for me. But it doesn't. It's not only applicable to liner shipping. So what the discussion is does minimizing the cost of the company actually also minimize the emissions? And we're going to look a little bit at that. Yes. So I don't know how much I need to talk about this. This is a liner shipping network. What we are going to look a little bit at in our test instances is that there's a transit time. So you have to, from a port A to some port B down here, there would be maybe some requirements that it has to arrive at a B within this period of time. So in this work, we're not going to look at transshipments and all these kind of things. So the transshipments, so we're only going to look at a single service, and then you have the transshipment time is kind of a way of dealing with the transshipment requirement that you can reach your connection on time. So of course the companies want to reduce costs, and especially now. I think before they were a little bit more like they wanted to increase number of customers, but now they want to reduce their costs so they can, because the freight rates are really low, and they want to be competitive with these freight rates. And so you have this type of bunker consumption. Usually, so this is a cubic curve, and this is what is theoretically assumed, that the bunker consumption is a cubic curve, but it is some sort of a curve. If it's cubic or non-cubic, it all depends. But the key is that the lower you sail, the slower you sail, the less bunker you use on the entire journey. So what we are kind of considering for a problem is so we have the total time of a rotation is a number of weeks. So we have this number of weeks that has to be satisfied. So for our route, it has to equal some number of weeks. So you can add and subtract vessels at some charter rate, and there's some. Actually, in the example I'm going to look at later, we don't really consider channels because it's outside of that area. But for other examples, the channel costs are included. The instance is part of the liner lip, taken from the liner lip, which David described earlier. And then we have fuel consumption, and because we can sail infinitely slow, then we also have some idle consumption, because you cannot reduce the consumption infinitely. There is some limit to where you actually increase the consumption because you extend the time that you that you use on the journey. Yes. And this is just an example of a route where you have these pod visits. Yes, so we kind of use a TSP structure, but the transit time ruins this term of using a TSP to start with. So you can't say that the shortest route is also the cheapest route, because you have the shortest distance will also introduce the cheapest amount of bunker, because you have this transit time constraint. Okay, then we go into the emissions. So we have the the sulfur oxide emissions, and that causes acid rain and respiratory diseases. And there are some regions, the Baltic region, Sea region, the North Sea, which is kind of a connected region, and North America coastline, and US and Caribbean. And then here in 2020, it's actually supposed to be also for the rest of the world. There's some bunker, some reductions. Oh no, I think no. This is the US Caribbean is supposed to be. Now I don't remember, but the sulfur is supposed to be reduced in 2020 or maybe later to 0.5% sulfur. And then we have the nitrogen, and that's basically the same health issues they cause, and and that's in North America and the U.S. Caribbean. And the carbon dioxide, which is a greenhouse gas, and that affects the climate, and then this particular matter. So today, what we are going to look at in this example is the sulfur and the carbon dioxide emissions. And we are ignoring the nitrogen oxide and the particulate matter because we are looking basically at Europe. So we have these, so these are the red ones are the current emission control areas, and the yellow ones are suggested emission control areas. And so the question that I actually wanted to pose by this is that by these emission control areas, do we really get what we want or what we need? And how do companies, how do they change their operations according to these emission control areas? And we can assume that we can assume that companies, they want to reduce their costs. They don't want to use extra money on something that is not required. But they also want to satisfy the requirement. They don't want to have the media come up and say, getting a fine, at least not the big companies that also care about the image. They want to satisfy the requirements. So do these requirements that we have here with the eco-zones actually do as we want? So we've made this model that has all these requirements that I said earlier, and we have the bunker consumption in, so Z is the zone, so it could be a non-ECA zone or an ECA zone, or CECA zone here. And then this is for sailing, and this is for idle time, and then there's some kennel cost and some charter rate. So this is basically our objective from the company. They want to minimize these costs. And so for the bunker consumption, since it's a non-linear function, and we want to make it a linear program, then we have approximated it by a large number of secants. So what we have done, what we have looked at is the bunker type 380, which is the one with 3.5% sulfur. And this is the amount of CO2, and this is the amount of sulfur. And this is the price of the bunker. And this is the bunker that is required in the ECA zone at 0.1%. And this is the amount of CO2. So it has a slightly higher CO2. And this is the sulfur amount, which is low. And this is the price of the bunker. And then we've also gotten some numbers. This is gotten from this handbook, because to me these numbers are a little bit hocus pocus, so luckily some other people are capable of calculating these numbers, but this is actually the environmental expenses. So what is the expense on our health and our environment? And so it's assumed that it's $37 per ton of CO2 and $12,700 per ton of sulfur. This is what they have calculated here in this report. So we have a second objective. So what we look at is if we, instead of just taking the cost, which we have here, we actually add an additional cost here. So this is the cost of the bunker, like what you pay for your bunker you purchase. And this is the cost, the external cost that the emission introduce here. So we kind of have split the term up in two kind of, one for the bunker and the same again for the emission cost. And then we again have these other costs for the company. So let's assume that the company also had to pay for the environmental cost that the rest of us have to pay. And we've looked at this instance that goes from here down in Morocco, and it goes up here to the Baltic Sea. And as we talked about earlier, here's where this CECA zone starts. And so we assume, so we have these different test instances. And later on, we will focus on this one, the I3, which has the transit time. But we have this difference with different transit times and different, where some birth times are fixed. And we have calculated. So, oh, yes. So what we assume is that, of course, when you have these CECA areas, you want to use less bunker. So what you do is you slow down. So you slow down within here, and then to catch up, because you have the transit time, you will speed up outside the CECA zones. And so the question is, I mean, there's also people living in Casablanca and Agadir, which can just as easily get a respiratory disease as we can. So the question is the overall, how is the overall pollution on a journey like this? And I think this is actually, I don't know if it is currently, but has been one of Maersk's routes is taken from their page. So we look at here. What we have done is the first model, M1, is without the external cost, and M2 is the model which optimizes with the external cost. So we have separated into the sailing cost. For the company, if they want to lower their cost. But here, in this case, the emission cost is not included in the company's objective. So the emission cost is higher because they're just operating from the perspective of lowering their own cost. And then you can see the total cost to the environment, and here the sailing cost for the company, and then the emission cost, which is much lower here, and the total cost here. But you can see there's a big difference in the emission cost and the in the emission cost between the two models. What you have as an objective, and the difference in the sailing cost is actually not as big. So there's not so much extra the companies have to pay to actually save a lot of money on these external costs for the environment. Yes. And we'll take this one out, which has 2 transit times. So it has these requirements for the transit times that it has to reach. And we'll look at that one in details on the emissions. So we have it here again. And so we look at here, this is the one with the, where the objective was only in respect of cost of bunker. And here you can see that the CO2 and the SOx, the sulfur outside of the eco zone, this is outside of the eco zone, how much is used here, and this is very high. And then you can see inside the eco zone here. And you get these total in amounts. And on the other side, you can see that this is outside the eco zone if you do the external cost as well. And the sulfur outside on the part outside the eco zone is much lower, because now you don't have this fuel cost, but you also have the external cost. So it's natural that it would reduce this. And the CO2 cost inside the eco zone is higher, and the same with the sulfur is a little bit higher. So you can see that that in total you get a much lower sulfur emissions. Or these are the emissions, and you get a much. So these are the amount of emissions. I said cost, but I meant emissions, the tons, and compared to this from the company cost perspective, the CO2 is a little bit higher. But the question isn't it okay that it's just slightly higher when you reduce the sulfur so much? Yes. So, I guess it's a little bit short, but the big questions here is actually, is the current implementation of the eco zone actually helping the environment the desired way that we desire? And could these regulations be done in a better way? I guess now the IMO might lower the sulfur emissions all over the world. So in that way, the difference between the two zones is not as significant if and when that is done. And also maybe there's nowadays I read somewhere that somebody said that it's nearly impossible to be caught cheating with the ECA requirements. So it means like it's very, very hard to catch the cheaters on the ECA requirements. And maybe there's some other way that it could be done. For example, when some monitoring way. That's part of the project as well, the Maneco project. It's not something we're looking at yet. It's Christos is going to look at that in the future. Yes, so there's a little bit on the model. The model is fairly simple model, or not so optimized, so it could be, I mean, some work can be done on it, so it can solve a large amount of ports, and maybe it could be verified by the industry in some way. Yes. And then, so maybe we would, I mean, it would be nice to compare to the current solutions. What is the current solutions that they operate from in terms of speed, and how is their emissions currently, and how could it be optimized? And maybe this was just an initial model, so introducing more transit time, 2 transit times is not really representative enough for with network. You would probably have 8 or 10 on something with 8 ports. And then you could also maybe have some demand into the model if you wanted. Yes. That's it from me. And I think I have oh, I forgot. I usually have a question slide, but I didn't add it to
I should ask if there are any questions. So, any questions for you?
Yes. So when you optimize speed on the service, how much flexibility is there to optimize the speed? Like David was telling that you have all those time windows, and then the program becomes difficult to change.
Yeah, but since I only there's a lot of possibilities, because here, I mean, that's one of the maybe you can say issues with the model, but I don't have very many transit time restrictions. So, and it's like it also has a routing option into it, so there's a lot of flexibility. So you can you can rearrange the order you select the port visits in. Yeah.
Line, I think you had it in one of the slides. What is the average speed in the SEC area and outside the SEC area?
Oh yeah, I think I had that in this. Yeah. So let's see. So of course. This one is a little bit because they add, or the model added another vessel. But if we look at this one, then if you have for the company's perspective, let's take this one. That one is more fun. That's also the one they're selling. Then they have 16 outside the ECA and 13 in the ECA. And actually they changed it around a little bit here. But that could be due to some transit time. I think if I go back once, so number I1 doesn't have transit times, and I4 and I7. So let's see. So if we go and look at these ones, but they actually speed up a little bit inside the ECA. If you look at the emission cost, so before it goes slower in the ECA compared to outside when they look at their own cost, when they optimize in terms of their own cost, and when they optimize in terms of the environmental cost, they speed up slightly inside the ECA. Because to make the time so they can slow down outside, because the external costs are so expensive. You can also, I mean, it's basically everywhere. You can see it here as well. They have this reverse here. There's a reverse as well. And here, and where was it? The 7. Actually, this one doesn't have any changes. Yeah. But yeah. So they actually reverse it, the speed. So it is more expensive for the companies, but the sailing cost is not that different because they still probably stay within. I think the max speed of the vessel here is 24. I believe it was 24. So they're still far away from where it really consumes a lot, the peaks. Yes.
More questions? I have a small question. So if in one of your last result slides, you said that there was this paradox that you were using slightly more CO2 emission, but you reduced the sulfur considerably. Could the explanation be that the low sulfur bunker, when you remove the sulfur, then you have more oil in it. Actually, it has more energy in it.
Yes.
And then you will not use, so the fuel energy is bigger in the low sulfur, so you would also use fewer liters.
Yeah.
So this could come from this fact.
So they actually have the low sulfur bunker has a higher CO2
because there's more
emission
coal
per
in it.
ton. Yes.
Yeah.
It's because when you try to extract the silver out of the oil, then you consume energy.
Okay, but that's
This gets at the end. It gets into your per liter.
Okay.
But it is energy that you have consumed in the refinery.
Okay, so it's
Okay,
already
so it's
in
I
the
didn't know
past.
that.
Because I thought that if you have removed 3.8% sulfur, then you have space for 3.8 more real bunker. And this means you can also run 3.8% longer on a liter.
No. This 3.8 has nothing to do with the carbon content of the fuel.
Okay.
No,
So the burning value is absolutely the
Yes,
same.
the burning value is the same.
Okay. I have a last question then. Do you think that we will ever get this global ECA areas if you are saying that it's so difficult to catch people who are cheating?
I think it might be introduced, but I am worried about whether or not it will be, what do you call it? It will be if people will comply with it.
Yeah.
About the compliance with the ECA zone.
Yeah. This will be a paradox because those who are cheating, they can offer lower freight rates.
Yes.
And they will get even more containers. But those who actually try to satisfy the rules, they will go bankrupt.
Yes. I think this is one reason why Maersk is very active in this area, because they want to make sure that the compliance is the same, because otherwise if they satisfy the rules, they will lose in the competition, or may lose.
Will they continue selling this the bad fuel if you have larger ECAs? So maybe then you have to stay longer to actually get that.
But let's say that it was Russian ships and they start in Russia and nobody knows what's in the tank. So then you have to go and check what's in the barrel.
And you have to trust some of the countries, and I think maybe some countries have governments where regulations are not kept as strictly.
I think George was first and then Marinos.
But if I'm not mistaken, a recent report I saw for the Baltic Sea, the compliance is quite high. It's above 90%, 95, around 95% compliance with the second. So it's not that hard to comply, or at least in this part of the world and also the States. Compliance is okay. Of course, Russia, as you said, is a bit of a problem.
But there's still sometimes you can get a fake certificate, and so even if you check with the compliance, you might not know if the compliance is real.
No, they go. They're using drones now.
Or the sniffers, if they have sniffers, then they can
check.
check
The problem
for
must
sure.
be in the deep sea, in the middle of the ocean. Who will ever come there and check what we're doing?
But there will be a global cap of 0.5%, either in 2020 or 2025, and the decision is this week at the MEPC.
So we must cross our fingers.
that there is a study that shows that there is enough fuel to be implemented early, and there's another study that shows exactly the opposite. So they have to study the two studies and decide which one is the best.
Okay, so should we say thank you to Line?